Um, okay, derivative notation. So first that you'll see is this. F, this means f prime of x, which means the derivative. F prime of x. That little mark floating above looks like an exponent, looks like a 1. It's not a 1. It's a prime. F prime of x means you're looking at the derivative, or you're finding the derivative. People will also say y primed, okay, which means the derivative. The other notation that is common is dy over dx, which is the derivative of y. WRT. WRT means with respect to x. Okay? This notation is important when we get into word problems and rate problems and things like that. And the other one, sometimes you see, although we won't really use it in this class, I don't even think I used it in university, is this d of x of y. The derivative of x with respect to y, or the derivative with respect to x of y. I don't even like this notation, it looks weird. The ones that we will use are these three. Okay? Those are the most common ones. All right. Okay. So let's talk about derivative notation. Derivatives that don't exist. Because it's a limit, right? The derivative is a limit. Okay? There are limits that don't exist. So that means there's derivatives that don't exist. So and you already know most of these don't exist. Who can think of one where the derivative wouldn't exist? Think of limits. Think of it in terms of limits. Oscillation. I like that, but there would still, because it's a continuous function, but we could say at the point that it doesn't, like if a point doesn't exist, like on that oscillating graph, there was a point that didn't exist. So if you have undefined points, i.e. a hole in the graph, if you have a graph that looks like this, say f prime of c does not exist. If you don't have a point, if the point doesn't exist, the derivative can't exist. Okay? If there's nothing there, you can't do a derivative. Think of it in terms of drawing a tangent line. You can't draw a tangent line through a point that does not exist. What are other points that don't exist? Asymptotes. So vertical asymptotes. Again, it would be the same reasons, right? You can't have a derivative at a point that does not exist. And the last two will be a little trickier. Does anybody know if you have a vertical line like that? What's the slope of that? infinity, right? Because a horizontal line has a slope of 0, that has a vertical line is a slope of infinity. And since it's a limit, if the limit is equal to infinity, does the limit exist? No. So vertical tangent lines. So vertical tangent lines. So does anybody remember, you've all taken Chem 12, right? Or if you did, do you remember buffers in Chem 12? Remember a buffer graph that looks like this? Remember those? Everybody's saying, nodding it with such happy faces. Everybody loves chemistry. Well, there was that point. That's a really bad line, but that's a vertical tangent line. Okay? The derivative does not exist at a vertical tangent line. Okay? So if I called that C, again, f prime of C equals D and E. And the last one, it's not totally intuitive, are sharp turns. And these make more sense once we get into the power rule because you can actually see it. But this point right there has no derivative. Okay, the derivative does not exist at a sharp turn. Okay. And the reason why is technically all you need to know is that derivatives don't exist at sharp turns. But the reason why is the limit as x goes to c of the derivative from the right side. In this case, I'll just make up these numbers. Would be -1. All right, this is a negative. Sorry, you can't see my hand. This is a negative slope. Sorry, that's a positive slope. Jesus, I can't do math today. Sorry. And coming from this side is a negative slope. I'll just make these numbers up, positive, -1. Since the limits don't match, the limits don't exist, or the derivative doesn't exist. The other way you can think about it, that's not sort of real math, but how do you draw a tangent line at a point if you only hit the graph once? I could draw it like that, I could draw it like that, I could draw it like that, I could draw it like that. Essentially, how do you draw the tangent line? We don't know, so the derivative doesn't exist. The other thing that has sharp turns, that looks like an absolute value graph. Sometimes you'll see stuff that looks like this. These are called cusps. And we'll talk about those later on. You get them when you have fractional exponents. Okay. 12 more minutes. We can start power rule today. It's the most simple rule of derivatives, and it saves you having to do all that limit stuff. Okay? So, and then this will be it. This stuff is not on your test on Monday. It'll just be limits on Monday. Oops. Okay. So differentiation rules. Constant rule. So if I said, what is the derivative of, I don't know, let's make it 4. So this notation means the derivative d with respect to 4 with respect to x, i.e. what's the derivative of 4? So let's think about it as a graph. If I said y is equal to 4, what does that graph look like? What does the graph of y is equal to 4 look like? Horizontal line. Just click that. What's the slope of a horizontal line? 0. What does the derivative represent? The slope of the tangent line. In this case, the tangent line is the same line. So what's the derivative of 4? 0. Okay. So the derivative of any constant equals 0. 10, 50, 100, negative 4,000, whatever. If it's a constant number, its derivative is 0. All right. The power rule. This is the most common in first year, and everything else we do is sort of a variation of this. I'm going to write the rule, and then we'll just practice it. So it says the derivative with respect to x of x to the n, so x to some exponent. All you do, take the exponent, drop it down in front. So I get n x to the n minus 1, and take away 1 from that exponent. Okay? This saves you having to do all that limit stuff. All right? The exponent falls down, you take away 1 from it, and you're done. So it works when you have polynomials. So if I say f of x is equal to x cubed, and I want to know what f prime of x is. Again, this means this, right? These are the same thing, just written differently. So if I want to know what the derivative of x cubed is, what do? What happens to the 3? Put it down in front. So I get 3x, take 1 away from the exponent, so it becomes 2. That's the derivative. You're done. 3x squared. Okay? If I say f of x is equal to the cube root of x. In calculus, we don't like roots. We want to rewrite everything as exponents, okay? Because then that allows us to use this rule. So how do I rewrite the cube root as an exponent? 1/3. So this means x to the power of 1/3. Once you have it in exponential form, exponential form, then you can use the power rule. So what happens to the 1/3? Drops down. So f prime will be 1/3 x. And now you do some math. I know people don't like fractions, but this is what you have to do. So we take away 1 from 1/3. It's going to mean negative 2/3. But if you go like that, that's what you're doing, right? So you're going to get a common denominator. You're going to go 1/3 minus 3/3. Subtract the numerators. Negative 2/3. So it becomes x to the negative 2/3. Is that okay? All right. Y is equal to 1/x squared. I want to know what y primed is. If you have an exponent in the denominator, we need to get it out of there. How do you rewrite that so that it's not a denominator? Flip it up, which makes the exponent negative. Yeah. So it becomes that. Now we can use the power rule. So y primed, drop the -2 down, take away 1, so you get x to the -3. You could leave it like that. You could write it like this. Doesn't matter. It's all the same thing. Okay? I think I can stop there and pick it up on Monday. Maybe a couple questions. Here's the questions to do, please. 114 numbers. Yeah, you only have to do a few. 3 to 9. Odd. That'll take us at the break. On the other side of break, because we're done at 11 today, I'll outline the test on Monday, give you your reviews, and it'll just be practice for the rest of the class. Stefano, you're going to do these in about 6 seconds. Vinny?
I don't know.
Don't want to know.
Almost.
You timed it. Hey.
Okay.
It's break time, people. I'll outline the test when we get back.
So once you're here,
So this is right.
we should get I was doing it up here.
Oh, I see. This week. This is fine. Oh, I see. Where you can. I think you can. You gotta remember this. This is the body. So that's I. That's going in. I don't do it. So this is right. Yeah. Or what?
But also.
Okay, that one.
No, it is. Is this one?
So
I just can't seem to wrap my head around that you're not putting in.
some people like
I put in. I put in two.
Okay, what do you do?
It was meant to.
At the bottom, you have to remember your audience. Because you're going towards three. That kind of like
So if there's
weird.
one on the top, at the bottom has zero.
Yeah, because this is a pretty one. So you just have to figure out if the graph's going back or